Hey everyone, my name's Trevor, and in this video I'm going to show how to persist variables between multiple ink stories in a Unity project. For example, if we choose a Pokemon in this dialog, we can persist the result of that choice and then reference the Pokemon that the player chose in other ink stories. As an added bonus at the end of this video, I'll also show how to reference that persisted information to change something in the actual game. For this video, we're just going to change the color of this other NPC based on the Pokemon we choose during this dialogue. And just a quick disclaimer, we'll be starting this with a dialogue system that's been built up in some previous tutorials that uses ink and Unity. You don't need to have seen those videos to understand the concepts presented in this one. However, if you find yourself lost or need a bit of extra context, I'll put a link to the playlist containing those previous videos in the description of this video. The main one you'd want to watch is the dialogue with choices video, as it contains the bulk of creating this dialogue system from scratch. And of course, as with any of my tutorials, the source code for what we are about to do can be found on GitHub, which I'll also link to in the description of this video. With all of that said, let's take a look at how we're actually going to do this. For the dialogue system we're starting with, how it works is that we have separate ink files for each NPC. When the player talks to an NPC, we send that ink file off to a singleton class called the dialogue manager that creates a story object from that ink file, which it uses to play through and display the dialogue for that NPC. The problem here is that because ink stories are self-contained, we currently can't have the dialogue of one story affect the dialogue of another story. For example, in this dialogue, when we choose a Pokemon, other stories won't have access to the result of that choice, which prevents us from being able to reference the Pokemon that was chosen. There are a lot of ways we could go about passing around information between ink files and Unity, some of those being tags, external functions, or even creating our own game-specific text parser. While all of these will work, and some may be better or worse depending on the specific situation, in this video we're going to use something called a variable observer, which I believe creates the most flexible solution that will work well for the majority of situations you might find yourself in. How it's going to work is that we'll create a separate ink file in the project called globals that we'll use to define any variables that we want to be available to all of our ink stories and also in our C# scripts. Other ink files will use an include statement to include those variables. Then in our C# code, when we first start up the game, we'll store the initial state of all of the global variables in a dictionary by reading in the globals ink file. Next, whenever we start a new story, we'll attach a variable observer. The variable observer will essentially listen for any time a variable is reassigned while the ink story plays out. Whenever that happens, the variable observer will pick up the change and will update the dictionary to store the new state of that variable. Then when we start another story, we can load the current state of all of the global variables into the story from the dictionary. So that'll let us keep the state of ink variables across different stories. Then on top of that, if we make the dictionary publicly readable, we can reference the current state of any ink variable across our C# code, which will enable us to change things in the game based on things that happen in the dialogue. Just to summarize, we're going to create a globals ink file to store any variables that we want to use across different ink files or in our C# code. Then we'll store and maintain the state of those variables in our C# code through the use of a variable observer. And finally, we can publicly expose the dictionary that's storing those variables so that other scripts can reference the variable state. With all of that said, let's jump into Unity and start implementing this. First, I'm going to create a new ink file called globals and open it up in the Inky editor by double-clicking it. As I mentioned, this is where we'll declare any variables that we want to use across different ink stories. For the sake of this example, I'm just going to declare one variable here, which will be a string called Pokemon name, which will initialize to an empty string. Then back in Unity, I'm going to open up another ink file called Pokemon.ink, which was created in a previous video and is already attached to one of the NPCs in the scene. For this dialogue, we're simply given the choice of 3 Pokemon, and then we're displaying the choice after it's been made. At the top, we'll add the line include globals.ink, which will allow us to reference the Pokemon name variable we just declared. And just to note, for the include statement, you can use relative pathing to go forward or backwards a directory from where the current ink file is. However, for this example, all of the ink files in this project are in the same directory, so I won't need to do that here. Then at the bottom of this dialog, after a choice has been made, we'll use this tilde symbol to indicate we want to do a variable assignment and then set the Pokemon name equal to the Pokemon variable coming into the knot. For this example, after the Pokemon has been chosen once, we don't want the player to be able to choose again. We'll add another knot called already chose, which will just tell us which Pokemon that we've chosen. And then towards the top, we can add a conditional statement where if the Pokemon name is still the empty string, we'll go to the main knot, allowing the player to choose. Otherwise, we'll send them to the already chose knot. And next, back in Unity, I'm going to create another ink file for a new NPC we'll create in just a moment. We'll name this file Pokemon NPC and then double-click it to open it up. At the top of this file, we'll include the globals file so we can reference the Pokemon name variable. And as for the dialogue, we're going to keep things really simple just to show that this works. If we haven't chosen a Pokemon yet, so the Pokemon name is an empty string, we'll just make the dialogue ... But if we have chosen a Pokemon, we'll print out the Pokemon name followed by an exclamation point. Then back in Unity, we'll drag out our NPC prefab from the prefabs folder to create a new NPC. I'm just going to resize them to be square, change the color to be white, and then position them right in the middle of the scene. And of course, we'll drag the Pokemon NPC inc JSON file into the dialogue trigger script for this new NPC. If we go into play mode, we can talk with each NPC, but you'll notice that the state of the Pokemon name variable isn't being persisted across different ink stories just yet. Back in Unity, we'll create a new C# script called dialog variables and double-click it to open it up. This script is where we're going to store and manage the state of the global variables. We're going to treat this as an object that can be created and used by another script, so we can remove these start and update methods as well as mono behavior up here at the top. Let's start by creating the variable observer function. When a variable changes in our ink story, this is the function that will get called. We can name this function whatever we want to, but I'm going to call it variable changed. It needs to take in two parameters, the first being a string, which will be the variable name, and the second will be of type ink.runtime.object, which will be the value of that variable. For now, just so we can more easily see how this works, let's add a debug.log statement to print out the variable name and the value for any time the function is hit. For the next part, let's add using ink.runtime at the top of the script. To actually hook up the variable observer function, we'll create two public functions, start listening and stop listening, both of which will take in the story object that we want the observer to listen to. In the start listening function, we'll use the line story.variableState.variableChanged event plus equals variable changed to add the variable changed function as the listener for when a variable in that story changes. Likewise, in stop listening, we'll do the same thing but use minus equals to remove the function. This is just a best practice so we don't accidentally have listeners hanging around in the background. Next, we actually need to create a dialog variables object and call these functions when we enter and exit dialogue. This is going to depend on how your dialogue system works, but in this system we enter and exit dialogue using a singleton class called the dialog manager. So I'm going to open that script up. At the top, we'll create a private dialog variables object and call it dialog variables. Then in the awake method, we'll set the dialog variables equal to a new dialog variables object, and in this script, the entry point where dialog starts is in a method called enter dialog mode. Right after we create the ink story object, we'll call the start listening method and pass in the story. Then when we exit dialog in the method exit dialog mode, we'll call the stop listening function, which will remove that listener from the story. The takeaway here is that you want to start listening when you first create the story, and then stop listening when that story ends. And now, if we go into play mode and talk to this NPC, we'll see that right after we make our choice, a log statement pops up in our console indicating that a variable changed. The next step is going to be storing the state of these variables in a dictionary. Back in the dialog variables script, we'll declare a dictionary where we're going to map a string, which is the variable name, to an ink.runtime.object, which is the value of that variable. What we want to do is initialize the values for this dictionary by reading in the globals inc file. What you'll notice though, which is kind of unfortunate, is that because the globals file is considered an include file, it won't automatically compile down to JSON like the other files do. I wasn't able to find a way to make this compile in the editor, but I did find a way to compile it in our code. This isn't something you want to do regularly since the compilation process takes a bit of time, but it'll work fine just for this one special case. We'll create a public constructor, and as a parameter, we'll take in a string called global's file path, which will be a file path to the global's inc file. Next, we need to add a using statement for system.io. Then we can use this bit of code to compile the file contents into a story object. We're simply just reading in the contents of the file as a string, then using Inc's built-in compiler to convert that string into a story object. Next, we'll initialize the dictionary to be a new dictionary, and then we can loop through each global variable name in the globals file with this for each loop. For each variable name, we'll get its current value and then add that entry to the dictionary. We can also add a log statement here just to make sure things are initializing as intended. Then, back in the dialog manager script, we'll add a using statement for inc.unity integration. Then we'll add a serialize field, private inc file, global's inc file variable. And last, we'll scroll down to where we're creating the dialog variables object and we'll pass in global's inc file.filepath. Back in Unity, we'll now have this dropdown in our inspector for the global's inc file. We can leave all of these values as defaults and then drag in the global's file into the inc asset slot. And now if we enter play mode, we'll see that the Pokemon name variable is being loaded into the dictionary at startup just like we wanted. The next thing we need to do is that when a variable changes, we need to update the dictionary with the new value. In this case, we only want to maintain variables that were already initialized in the dictionary, so we'll check if the name is contained in the dictionary using the contains key method. If it is, we'll remove the old entry and then right afterwards we'll add the updated entry with the new value. So that'll maintain the current state of variables, but we'll also need to load those variables into each inc story. We'll create a new function called variables2story that takes in a story object, and then we'll loop through each entry in our dictionary and call story.variablestate.setGlobal and then pass in the key and value. Then we'll call this method right before we add the variable observer in our start listening method. And just to note, this call does need to happen before we assign the variable observer, otherwise you'll get an error when you try to run this. Back in play mode, we can talk to this NPC and choose a Pokemon, and now if we try to talk to them again, they won't let us choose again just like we specified in our inc logic. And likewise, if we talk to the other NPC, we'll see that the Pokemon name variable is carrying over between the different inc stories. This shows that we're persisting the state of the Pokemon name variable as intended. But what if we want to do something in our game, for example change the color of this NPC based on the Pokemon that we choose? This actually ends up being pretty easy given the system we've set up. Back in the dialog variables script, we'll change the dictionary to be publicly readable with this syntax here. Then in our dialog manager script, we can add a method called getVariableState that takes in a string for the variable's name. We can then reference the dictionary in the dialog variables object, and assuming the variable exists, we'll return it. And if the variable doesn't exist, we'll do some logging to let ourselves know. Back in Unity, we'll create a new C# script called Pokemon NPC and then double-click it to open it up. This script will change the color of the NPC it's attached to depending on which Pokemon we choose. We'll create a color variable for the default color of the NPC, as well as 3 more colors, 1 for each choice. We'll also create a private variable for the sprite renderer. Then in our start method, we can get a reference to the sprite renderer using the getComponentInChildren method. Then in the update method, we can get the current state of the Pokemon name through the getVariableState method we just created in the dialog manager. We'll need to typecast this as a string value since it's a string, but if this were a boolean, float, or int, you'd pick the appropriate inc.runtime object instead of a string. Then we can use .value to get the actual string value for that variable. Last, we'll just add a switch statement that'll change the color of the NPC based on the value of that variable. And of course, be sure to add the case for whatever the initial value is as well, which in this case is the empty string. Back in Unity, we'll drag this script onto the Pokemon NPC and then press play. Now when we make a choice with this NPC, the color changes on the other NPC depending on the Pokemon that we choose. And that's it. Thank you so much for watching. It really means a lot to me how many people have followed this tutorial series so far and found it helpful. If you like this video, please give it a thumbs up so more people see it, and press the subscribe button if you'd like to see more from me. I do have a Discord server that I recently started as well, which is a great place to come by and ask me questions, suggest a video topic, or even show me what you're working on. You can also follow me on Twitter or Instagram, where I mostly post updates for the game that I'm creating. Anyways, thanks again for watching, have an excellent day, and I hope this was helpful.